we are excited to begin our second panel discussion of the day, the shape of the robotics innovation ecosystem. Moderating this discussion will be Lindsey Mastis, news anchor at WJLA-TV. Please welcome our panelists, Dr. Ken Plaks, Director of the Tactical Technology Office at DARPA, Peter Haas, Director of the Department of Robotics at the Massachusetts Technology Collaborative, and Claire Delaunay, Chief Technology Officer at PharmNG.
Thank you so much. I'm so glad that you are all joining me on stage today. I'm so happy that everybody is here today as well. There is so much knowledge in this room, so I want to make sure that we are talking a little bit more in depth than I think we would a lot of times. I think a lot of our relatives and parents might say, what is it you do again? But in here, we really know. So I want to thank Ken Plaks with DARPA for being here, Peter Haas with the Massachusetts Technology Collaborative, Claire Delaunay, PharmNG, and I think we're also fortunate to be able to hear from all of you today, and we have so many different industries up on stage right now. We have government, we have industry, we have academia, but I really want to start out talking about the goods and the bads, right? So the challenges and the opportunities. So just really quick, I want you to, one by one, maybe keep it a sentence or two, just to say, what is the biggest challenge that you see, and what is the biggest opportunity when it comes to your sector? Ken?
I would say on the challenge side, a couple things. First is, I'm in the DoD, we don't really want to build Skynet, and so kind of trying to build ethics and comply with all the policies and legal and just kind of our Western norms with what are fundamentally weapon systems from a DoD context is a big challenge. Additionally, from a military perspective, the environment we find ourselves in is much more wicked, not as cooperative as, say, a self-driving car finds it in. Opportunity space is there's $100 billion, I think, of commercial investment, and so I want to ride that train and not reinvent that wheel. So that's a huge opportunity for the government. And then also, I think the United States just has a competitive advantage in kind of this creative, creating a whole new industry, both with our capital markets, our education system.
Peter?
So his opportunity is my challenge. I see the VC investment right now as being concentrated in higher valuation rounds, so $50 million and above rounds for a few select companies. And there's not enough money going into that sub $5 million seed round for the innovators that are trying to get their TRL level 6 prototype into a product. So we're seeing a real gap in alignment between the funding and the innovators who are trying to develop new robots. In terms of opportunity, I think there's a huge opportunity for long tail of manufacturing. The 750,000 robots, it's actually a little bit more now, that Amazon Robotics has deployed. They were built in Massachusetts by contract manufacturers, creating a lot of jobs in the state. And I think if we look at this industry as a whole, building robots domestically is not just a national security issue, it's an economic issue. And it's one that's going to help us really rebuild our domestic manufacturing base.
Claire?
Yes, so I would say the opportunity and challenges in robotics and agriculture, I think, are just two sides of the same coin. As you know, food is a very important cornerstone of our daily life. I mean, we all need to eat. But the reality is that there's less and less people willing to go to farming, just be out there and do the farming tasks. So we do have an opportunity with robotics to help and maintain basically small farm and a very big diversity of practices to produce food. Now, the main challenge that we have also is that there's actually no money in agriculture nowadays. The margins are extremely small, and that's not something that most of the VCs are interested in because it's really hard to explain that they're going to be a 10x return on investments in the next 3 years. So we really believe, me and my team really believe that robotics can help us rolling out practices that are more regenerative for the ground and be able to basically maintain a lot of diversity in what we grow and not creating just monocrop culture. However, it will take a lot of factors at the table to make it happen, not just roboticists, I would say, but as it was mentioned just before me and also this morning, building robots in the physical world is really hard. Farming is even harder. There's a lot of dust, there's a lot of heat. I mean, it's not space, but it's not the most, like, it's not a factory either where everything is controlled, right? So I think it's very difficult to roll out robotics technology over there. But even if we all believe that there is tremendous opportunities.
So a lot. I love how there's so many opportunities, challenges, and maybe opportunities to work together. Ken, I want to talk about DARPA. DARPA's been at the forefront before for other technological advancements and breakthroughs, but we have AI and robotics really coming together now, and I'm really interested to hear how you're envisioning those systems come together, especially when we're talking about autonomous systems, and then also what kind of shifts you see in the future as this becomes more prominent.
Yeah, one of the really interesting things about AI system, I used to fly jets for a living, did flight test, and it's really hard to test AI. Some of the large language models, they're statistical, not deterministic, and if you've got 1 million self-driving cars that are phoning home every night, that offers you an opportunity to get a large data set that you can curate, et cetera, and improve your modeling and your training data. We don't have that in the military. And so how do I test something? And again, the consequences of being wrong are, can be catastrophic with an autonomous weapon system. What we've done, we have a program, you might have saw on the internet about a year ago, we had a dogfighting robot in a simulator, and it beat this poor fighter pilot five sets in a row, and he's gonna buy beer for the rest of his life. We have taken that, now taken it out of the sim and put it in the real world, and we're doing that in a way that hasn't scared us. And the way we've done that is we've got the kind of the generative AI in a box, and then around the box we have what we're calling a sandbox that controls the inputs, and the actual flying AI is deterministic, and then the thing that tells it what to do while it's flying is not. And we've actually been able to update hundreds of thousands of lines of code, in weeks. Normally, to update the software on an F-16 takes about 1.5 years. With all the testing and everything and all the certifications. We can fly a sortie in the morning, update our algorithms, and fly it again in the afternoon, which is astonishing as a flight test guy.
Wow.
Yeah.
Yeah, and thinking about the history and then thinking about now and then thinking about 10 years from now,
Right.
what that might even look like. Peter, I want to talk a little bit about, have you talk a little bit about the components of technology, right? So you're bringing so many different people together. And I really want to know a little bit more about what you're hoping to build and what that future is going to look like and how it might even evolve over time, because I'm sure you have like in the year or two we're hoping for this, but 5, 10 years out, what does that evolution look like, especially when we're talking about this whole AI robotics ecosystem?
Yeah, sure. So Massachusetts has a very unique ecosystem. It's one of the 3 largest robotics ecosystems in the country, with over 400 companies doing robotics or doing robotics components. And we also have about 70 research labs in the state that are focused on robotics, along with a strong technical training resource in the state as well. So for me, one of the big things is to get people talking to each other and working together. It's really important to get the researchers working with industry to be able to translate some of these ideas, see some of these startups get funding from VCs, and really create that flywheel effect of innovation that's powered by VC money and powered by laboratory research, turn out new products that can create jobs in the state. So for me, that's one major component. The other major component is talent. It's really important to reach very early in the educational system to be able to help students learn robotics at the high school level, to get them ready for that research pipeline or ready for that industry pipeline. And right now we're seeing great success with engaging students in robotics at the high school level and at the K through 12 earlier stage level, because robots really sell themselves to kids. So it's really an exciting time. And in terms of where it's going, I mean, I see the opportunity to create a cluster of talent and capability domestically that is equivalent to a Shenzhen, that has that ability to locally fab chips. We have the Northeast Microelectronic Commons that's doing chip design and lab to fab transitions of chips. We have biomanufacturing taking place just north of Massachusetts in New Hampshire at the Army ARMI, not ARMY, Research Center. We've got the huge biotech industry in Massachusetts. So there's an opportunity to create convergences between these different industries and really generate a great amount of economic activity in a small area.
And that kind of leads me to what I'm going to ask Claire as well, talking about trying to bring all these different industries together. So Claire, you've had a lot of experience with Google, with NVIDIA, and now you're into the startup world. And what do you see as the strengths of having the large companies and then the strengths of the startups and maybe more ways to collaborate?
Well, that's a difficult question. But, I think I really believe that there is something magical about diversity, and I'm saying it because I'm, of course, obviously a woman in robotics. There's not a lot of them, especially when I started back in 2001. But I'm making that point because I was given the opportunity to learn robotics the way I wanted to be, because even when I started, there was not really a courses in robotics, at least not in France. And so I was able to choose what robotics meant. And I really believe that what it gave me is really combining disciplines that were not necessarily taught together, and learn by that means to build robots in a very efficient way. So, and I think in a big company, the big advantage is that you're going to have, of course, a lot of budget to be able to experiment and deploy and develop technology. The challenge is that, especially if you are a secret project in a big company, you're also going to create an echo chamber where you basically also end up believing what you are building is the best without ever getting insights from the outside to check back your assumption. Now, in a startup world, you have the other problem, which is you have a lot of exposure to what's going on all around you, and you also have a lot of pressure from different points, from the market, from the competition, to actually deliver something that works with very potentially limited budget. And I would say not in all robotics. I mean, a lot of young startup, especially like the last year, I would say, got a lot of investment, especially on the humanoid robot sector. But for the rest of robotics, like ag or more conventional robotics, it's still very difficult to find capital and be able to raise money under the promises, again, that you need to do a 10x. And the reality is that we are still pretty far away to be able to deploy any of these robots in product and real life environment, especially on the humanoid side, I would say. So,
yeah, it's eye-opening to see, you know, what you're seeing, of course. And I know that when it comes to DARPA, you know, there are things that the government can do and things the government cannot do. So when we talk about private-public partnerships, tell me a little bit more about the role and how that might drive innovation and what you see, and we have everybody up here, you know, what you see in terms of government working with industry, working with academia.
Yeah, you know, yeah, I don't want to burst anybody's bubble, but there's actually no laboratories at DARPA. It's just an office building. And so what we do is we fund research, both in industry and in academia. You know, about 20 years ago, I think 20 years ago this year, we did the self-driving challenge. And the first time we did it, I think you know, you were supposed to drive from Bakersfield, California to Las Vegas. And the first year we did it, the best entrant got about 7 miles into the desert before it drove off the road. A lot of the entrants caught on fire, and the very next year we did it, we had all but one of the contestants finish. So a lot of the robotic stuff actually started, you know, with that investment, the self-driving cars and the actuation and the vision systems, and trying to put this all together. So, you know, there is an ecosystem that got spawned by that, and today we're still doing the same thing. So we have an autonomous off-road self-driving vehicle program called Racer that was working with JPL. We had a gentleman up here from JPL earlier, and one of the JPL folks thought it was so good, their solution, that they actually spun off a startup and started a company. And not to be outdone, the University of Washington, which was the other performer on this, a professor, also started Overland AI, which is, again, another off-road driving company that then turns into bigger companies and bigger companies. So DARPA actually is very involved with that. We actually have we had a problem where people were basically poaching these spin-off companies and buying them up. Particularly foreign capital, and frequently it's not obvious to a startup, you know, if it's, you know, clean capital or if it's got, you know, foreign entanglements or whatever. So we started what we call our embedded entrepreneur initiative, where actually DARPA will take you and kind of get you a startup mentor into your company and help you actually raise capital that's good. And we've actually started a couple or collaborated with a couple of more patriotically oriented venture funds. And so we're kind of trying to create this ecosystem to incubate these companies so they can kind of get to that first product and actually stand on their own 2 feet.
That's good to know. I don't think everybody knows that.
Yeah.
A lot of startups, as you mentioned.
Yeah.
You know, speaking of startups, you know, Peter, your expertise, it's not just academia, startups, you're overseeing, is it around 400 company robotics ecosystem in Massachusetts. So, you know, what are you seeing in terms of the innovations, especially as you're bringing so many people together?
So, I mean, I think that what I'm seeing in terms of innovation is really around the physical AI space. So I think that especially in Massachusetts, we have a number of companies who are working on the fundamental foundational models for physical AI. And the approaches that are being taken are not just transformer based. So we have several companies that are doing these biomimicry, neuromorphic approaches that are really unique and are allowing for much smaller models that run with much less compute, that run a lot faster. I think actually today one of them, Liquid AI, is making an announcement for its foundational model release. So these types of approaches that are looking at the algorithmic basis of the solution are really what's going to help drive for the next step in the robotics revolution. I mean, it's been amazing what we've been able to accomplish in the past 10 years with the advances in vision, with transformers for decision making. This was already discussed earlier today. But we're really just at the start. There's still a lot of room left for us to create hallucination-free, explainable AI that's going to be very important for safety when you're deploying AI driving physical systems. So that's one of the areas of innovation that I'm seeing. And in terms of just bringing people together, I think just making people aware of the research that's happening is really important. So just doing conferences to highlight this research really can change the spread of an idea and get people access to the resources they need to commercialize a product.
As you mentioned, trying to make sure people know about it.
Yeah.
It's my job to make sure people know about it. There's so much that happens in a single day, it's hard to keep up with. And Claire, I wanted to talk with you a little bit more about being in the field, because when we talk about, oh, we're going to be in the field, you know, we are usually have an envisioning what that might mean, but you might be in an actual field. And you're working with robots that are on a farm. They're out in the, out trying to do things that in the past people have had to really labor and use their bodies, and it's such a big change for the industry. And I'm really interested in hearing from you a little bit more about these diverse environments, some of what you're up against when it comes to the things that I think a lot of us in here maybe aren't thinking of when you're trying to make a robot work, and then also keeping in mind it's all part of the ecosystem, not just of innovation, but of our ecosystem being able to get food on the table.
That's right, and maybe just to add a little bit more about the complexity of building a final robot, I think it's really important. It's really, really important to not forget that a robot is a physical machine in the real world. And so even if we solve AI, even if we suddenly solve AI for robotics, I wouldn't know what it actually means, but the reality is that the reason why we are so good is because we are a wonderful machine. Modern nature is the best engineer ever, but when you think about it, just the fingertip, you close your eyes, you can touch a surface, you would be blown away by everything that you can do just with the fingertip. We do not have the fingertip in robotics today. There's research projects working on it, but we do not have them yet today in a form that is mass producible, cheap enough and robust to noise to make actually good use of it. So, I mean, if you give a human brain to an octopus, I'm pretty sure the octopus will not be able to do exactly what a human is doing, just because the body is not the same. So the body is really important. And why it is important is because we need factories, and we need a hardware ecosystem, and we need innovation around these things to actually really roll them out, roll robots out in the field. And one of the reasons why I mentioned that also is because when you do ag, you are purely limited by what robots can do. And in particular, harvesting, which is one of the tasks today in specialty crops that is still heavily done by hand. The reality is that we do not have sensors that are precise enough to grab delicately a fruit and put it very delicately in a box without ever bruising the fruit, especially if it's a raspberry, for instance. You probably even try yourself with your hand to pick up a raspberry. If it's really ripe, it's really hard to get it out. So that's really something important. to acknowledge when we talk about robotics. Now, maybe something something else that is really important is we also need a lot of people at the table to be able to build these robots, train them, whether they are in ag or in other fields. In agriculture, so in my company, we started also a farm robotic challenge, helping training the younger generation to develop robotics application. Not only training, but also helping them imagining a new future. And I think that's what the DARPA did very well in the previous year with the self-driving competition, is it helped younger generation to project themselves in the future and basically do the experiment, what if we had self-driving car? What would it look like? Who would program them? What would we check? So I'm really bullish about this experiment that really allow a large number of people, whether they are on the hardware, on the software, on the decision, on the legislation, on all the aspects, to be at the table and really focus on, really imagine what the deployment of a technology would be like. And so the way we do it in farming is by providing these robots that are extremely low cost. So that was our assumption. We need to produce machines that can do autonomous stuff, but they need to be as cheap as possible, so that as many people as possible that are still gravitating, I don't know how, but around farming, can sketch themselves and imagine themselves still being there in 10 years because technology is coming. And so I really believe that it's really important for industrial and government and researcher to be at the table around this kind of initiative to make sure we sketch the future that we believe is the best for us.
And that leads me to my last question. We have maybe a minute or so each to answer this one. It's a big one, but we're gonna sum it up. If you had unlimited resources, global cooperation, literally everyone would say yes to every request you made, what would be one challenge, one big robotic challenge that you would solve that would revolutionize humankind? Clara, let's start with you.
Well, that's a difficult one. I would definitely start by splitting it out in different buckets. I don't think there is a one winner take all. I really believe on the theory of bottlenecks, which is once you solve one, you're always going to get to another bottleneck. And so I believe there's a couple of bottlenecks right now in robotics, and we should just make sure that we have, I mentioned it before, but on the sensing modalities, our eyes and brains are amazing. This is how we think about the world, but the reality is much more complex. We have a lot more sensor in our body that allows us to really be efficient at many tasks. So on the research on the hardware side would definitely be one. The other one would be manufacturing. It's still very expensive to roll out robots and to make sure they are working well. We need more help to be able to build these robots faster. And the other one would be, of course, on the software, and it was mentioned in the previous talk. AI today is mostly inference and regression on vast amount of knowledge. We haven't captured just yet the intent, which is really what drives. Like when you talk to ChatGPT, you give the intent. You are the one explaining what you are looking for. ChatGPT is not thinking about what he wants to do without you. In robotics, it's very different. Yeah. As I mentioned before, if you send a robot on a space station and he cannot communicate with the human, all the decision needs to be made by itself, and they need to be the right one. So this research area, I think, is still very important.
Yeah, and life-changing. So, Peter?
I would say the intersection of the demographic crisis and climate adaptation is going to hit us harder than we can ever imagine. There are going to be fewer working age people who are going to have to deal with major infrastructure problems, and we're going to need automation to help do things with less water, less energy, deal with forest fires, deal with natural disasters, deal with coastal flooding. So I think there's going to be huge opportunities for automation in rising to that challenge.
And Ken?
I'm the defense guy, so I'm going to be a little darker. DARPA gets credit for inventing the internet. We actually invented TCP/IP, and the folks that did that, I'm pretty sure, never envisioned ransomware or spear phishing some little old lady out of her life savings. We've already seen that AI can be very vulnerable. You've probably seen the things where you put a sticker at a certain point on a stop sign and it becomes a 45-mile-an-hour sign. So to a certain extent, AI is a tool. We're using it to triage mass casualty events at DARPA. We're using it to do biological research for new medicines, et cetera. But if I could do anything, I would do two things. You said one, but I'm going to do two. First, figure out how to actually make the AI resilient and trustworthy. I think with the internet, we were so focused on getting things done and trying to accomplish a mission, we didn't think about all the surety and safeguards, and so I would change that. And then on the other side, this genie is out of the bottle. Already the barriers to entry are much lower. You have the Houthis who, kind of live in caves, are sending robot boats to attack oil tankers in the Red Sea. So I would love to figure out a way to scalably, reliably, and affordably deal with this, because some people are going to misuse this tool.
Yeah. Thank you so much. There's a lot that we all have to think about. Ken, Peter, Claire, thank you so much.